Okay, so hello everyone. So this one is going to be a short video, okay, on the solution of this first problem of International Math Olympiad, which just concluded yesterday. Okay. So this is problem one, okay, from IMO 2023, International Math Olympiad. Okay. So why am I making this video? Okay. So it's because today I got to know that the Olympiad was happening and mostly not doing much Olympiad problem solving these days. I think it's been more than a year since I solved any recent IMO question. Okay. But today I just some blogs, they got to know that this exam has happened. Okay. And so I just decided to try. And somehow, mostly I'm not able to, but somehow I was able to do the first problem on my own. And because I just recently solved, so I just want to share the solution. More than the solution, I think the thinking process, because I was able to do it surprisingly on my own. So maybe the thinking process can go through nicely. So let me just share it. That's all. It's going to be quick. So problem one, the statement is like this: find natural numbers, okay, with the following property. If such that if D1, starting with 1, this arrange the divisors in an increasing order, some k divisors, then the ith divisor must divide the sum of the next. Okay. So this question doesn't naturally fit into any of the categories. That's how it should be maybe in Olympiads. Yeah. So when I first saw this question, the very first idea that comes in, and that's what I want to share. Like, how did the ideas come? Because once they come, small things, then you can work things out. So the first idea is this natural thing is what are the numbers that work? And obviously, we know that maybe prime powers work. Right? Prime powers work because their divisor sequence is particularly simple. So it would just be some ith one would be this, and similarly, right? So prime powers certainly work. It's true. And then we, as usual, let's try some small examples, and then we see that, like, if you look at 6, so this is what I did. So if you look at 6, then you have 1, 2, 3, and then you have 6, right? So this was 2 cross 3. Okay. And then obviously this doesn't work, right? So 2 plus 3. And then you can, now the thing is, which I was thinking is, when you start with 2 primes, then you make the simplest number, P1, P2. Okay? So when you start with 2 primes and make the simplest number, P1, P2, how can you generalize this? What are the 2 ways you generalize this? So obviously, one way to generalize this, when you see that this doesn't work, so this one doesn't work, right? This one doesn't work. Okay. Then how do you generalize this? So immediately tells you that product of 2 primes will never work. P1, P2. This will give you the divisor sequence would be, so I'm writing P1, P2, and P1 is less than P2. So always for me, Pi will be less than Pi plus, or maybe change the index. Okay. This you can see never works because of this. And then I'm thinking of this as an obstruction. And the nature of the problem is because something is supposed to happen everywhere. And so some small obstruction is enough. So this is the obstruction, and so doesn't work. So product of 2 primes don't work. And but then how, in what other way can you generalize this? Okay. So we are thinking that if we change this number, if I change this number to something, how does the divisor sequence change? And the divisor sequence becomes an extension of the divisor sequence of 2 cross 3, which means that it will continue to have this obstruction and therefore they will not. This is the way I thought, even though we not needed, but just, yeah, that no matter what you do, this thing, this piece will always be present in the divisor sequence, and there will be other things, but we don't even need to look at it. This will not. So maybe if I erase all this and write what we have got so far, and now the ideas are is easy coming about. P1, P2 doesn't work. 2 to the power n, 3 to the power m doesn't. Right. And now we can try to generalize this observation. You see, the reason why this did not work is because you had something like this. For 2 to the power n, 3 to the power m. The reason why this did not work is something like this. So essentially, what is happening is you had a prime, and then you had a different prime, and this kind of thing doesn't work. So you have a small prime, okay, and the next one is not that prime, but then the next one again uses the previous prime because it's a small prime, so it comes again because it's an increasing sequence. So this was the kind of thing. So the point is that now this happened in the first stage, but this can happen at any stage, and that is enough to say that those numbers will not right. So think about what makes this happen. Right? What makes this happen? And what came to my mind is this happens for the following reason. If you look at this generalization, maybe NM is better. And if P2 is not very big compared to P1, by big I mean very is in the sense of n. So if you have something like this, that P2 is less than P1 to the power some k plus 1, but it is bigger than P1 to the power k, then this is the way we should look. This is where you will get the same quantity. It's the same thing. So one can just show easily that this is where you will get the same. You will have this, and then you'll have P2. And then the next one has to be this. You can see there's no other possibility. You cannot have the other possibility will not work because P1 is smaller than. So again, the same obstruction is basically that obstruction, but it just gets scaled up by P1 to the power. So this basically shows that two prime divisors don't work. But obviously with that condition. But if that condition doesn't work, so the other situation is, what is the other situation? The other situation is if P2 is bigger than P1 to the power n. But this is also just the same. Where should you look for the obstruction? That's all you need to see. Where should you look for the obstruction? And you know where. You just have to look at this place. And then you know what's going to come. So there will be P2 and then again P1 will come, right? Because again the smallness. So again you can just see that it's a problem. Right? This is a problem. Right? So you can check. So it's pretty easy, I think. It's just that you have to understand that this problem just requires small obstruction. So we can then generalize this up. We can just upgrade this to saying that two prime divisors don't. So obviously we now are somewhat sure that three prime divisors should also not work. Somewhat sure of. But how do we show that? So I was thinking about this a little bit, and then basically it's just that the three prime divisors case you can reduce to two prime divisors, right? So if you have three or more than two prime, basically just more than two prime divisors, write it like this, and then you just look at what was I thinking before I came. I was wasting a bit of time in other thinking about some other things. Not. I'm just trying to share the whole thinking process. Yeah, I was thinking it will get complicated because of merging sequences and so on. Yeah, but then we decided to look at something like P3. So you look at the first time P3, and then you just need to notice that. So this is only P3, okay? That here no P3 can come, and it's easy. It's an easy observation. So basically, when any divisor comes, yeah, the prime factors that it contains have already come before. So it means that every time, so the prime always before some multiples of a divisor come, of a prime come in divisors, that prime has to come alone first. That's the observation. And once you observe that, then you see that no prime, no P3 can come, or no P3 and no P4 and so on can come. So this is only about P1 and P2. So because this is only about P1 and P2, you know what's up, right? So this will be some case. Let's say that the number is n, and obviously now this is become the bad notation for the situation, but something. Yeah, so some RNS, P2, right? Not necessarily n and m, but the point is that this will be like this, and then all the divisors of this will be this. So basically, this part will again be a divisor sequence. So we are just pulling out some nice properties of this divisor sequences and using them, not doing much specific. So the nice property about this divisor sequence is that when you truncate it at a point, then yeah, that may be wrong, but yeah, when you truncate it at these points, when the new primes come, then certainly the head of the sequence is again a divisor sequence. And in this case, it's a divisor sequence with two prime divisors. That we already know doesn't work. And because this doesn't work, so the bigger one will not work. So this means this has a position where there is a problem, where this condition doesn't hold. And that's it. So it means, and so this is just the, in a sense, is just, I think the word divisor, just calling it a divisor sequence, and then just thinking about some nice properties via which you can comment, rather than going into the nitty gritty calculation. One thing which I was thinking is that if you truncate it at any point, then is it a divisor sequence? Yeah. If you truncate it at any point, then it is also a divisor sequence, right? Because any divisor will be less. Yeah. So that's a good thing about this sequence. And then I truncate it at any point, it's a divisor sequence. That's the nice thing. Okay, that's it. Just keeping it very, very short. This was just mostly to share because there's some expert solutions, obviously, directly they get things, and yeah, I suppose one has to develop their own way of struggling and coming up, but still just to share, the ideas we can, but just solve it. Yeah. Okay, I'll try the other questions, and I don't know, this was probably a simple one, but so yeah, but let's